and teacher websites.
Can never tell what's, if it's, do I go to math? No.
Yeah, under the department, go to math.
Okay, up at the top right, go to math.
No, left. There's a left on the
the
outside.
department, go to math, okay. Probably was the same place.
And then she's like the third or fourth row down in the middle. Her name is Hamilton. Yes. And then the Unit 2 quadratics on the left hand side of her page. And then scroll down to
events. The purple evens only?
Hold on. I accidentally lost the, okay, I got it back. Okay, go to solving quadratic, the October 15th one. So 3 ones below the purple one. And the completing the square worksheet, I think. Yeah, completing the square worksheet. The one below that.
Okay.
And this is where we just got.
Okay. In the future, if you have this on your browser, just copy and paste it and put it into the GoToMeeting chat window.
Oh, okay.
And I can get to it instantly by just clicking on that link.
Okay.
We can save a little bit of time by doing it that way. Okay.
Okay.
Okay, let's go over these. Here, let me enlarge this so I get a little more writing space. Bring this up. All right. Completing the square is making a perfect square trinomial. That's what you're doing.
Okay. What's a trinomial?
This is a trinomial. It's got 3 terms.
Oh, okay.
So there is some C that makes that a perfect square trinomial, which means that I can make it be x plus some a squared. Okay, so that's what a perfect square trinomial is. And that's what you're always doing when you complete the square, is you are making a perfect square trinomial. Okay, so the only thing you really need to remember is the technique. Okay, technique's always the same. You gather those together, and you take half of the coefficient of the x term, and you square it. So what do you get?
So you take that and you take half of the x, the coefficient of the x term, so that's 30, right?
Correct. So half is 15. Now square 15.
Square 15, 15 times 15, having a brain fart.
Tell you what, you know, it's probably a good idea if you always have your calculator handy.
Okay.
If it's single digit stuff, I prefer you to do that in your head. But the moment you start getting double digits, calculator is going to be the quickest way for anybody to answer. Although I happen to know that 15 squared is 225. Okay. So if I had this, that is a perfect square trinomial. And furthermore, I can write it as x plus 15 squared. Always.
So basically, every time you do is you just split the x, the coefficient of the x term, and square it, and that's your c term.
Exactly the technique. That's all you need to know. Okay? So when they want to know the binomial, what's the binomial? In other words, that's a trinomial. That must be the binomial they're talking about.
Uh-huh, because there's only two terms.
Yeah, so that's x plus 15. And I think that's the answer. I don't know if you have to do it like that. Maybe you have to do it like that. Not sure what she wants. Your teacher a woman or a man?
It's a woman.
Okay, good. At least I'm using the right gender. Okay, let's do the next one. What's the coefficient of the x term?
The coefficient of the x term is just -1.
Take half of that, square it.
Negative 1/2 and squared equals, what is a half squared? So half times a half equals, isn't it like a fourth or?
Perfect, yep. In other words, here's what you're doing. Half times a half, you're just multiplying tops, multiplying bottoms.
Okay.
So C is 1/4. Now what's my binomial term?
X plus 1/4 squared.
Remember, the binomial term is always that coefficient half of it.
Uh-huh.
So it's x plus 1/2 squared.
Oh. Oh yeah, okay.
I'm going to produce that 1/4 by squaring x plus 1/2, because the last part of FOIL is 1/2 times 1/2.
Okay.
So this binomial term is always going to be x plus, sometimes minus, not always plus, but whatever you got when you took half of that coefficient.
Okay.
And in this case, it's not plus, it's minus.
Oh yeah, because it's negative 1/2.
The negative 1/2. I didn't, almost made a mistake there. Okay, let's scroll down, have a look at what else they're looking at here. All right. When you are completing a square, you are always isolating those two terms. You're isolating the x squared and the 8x. So let's write it. Let's put parentheses around it, and let's leave enough space to include what it takes to complete the square.
For the C term.
Yeah, I don't even like the way they did that. We're no longer looking at C, but yes, for the C term. Okay, notice that C is not in this anywhere. The way we're going to solve this equation, this quadratic, is by completing the square. Forget about C for the moment. Complete the square inside the parentheses.
So wouldn't it be, well, we obviously have, don't we have 8?
Go ahead and do it. You know how to do it.
4, and then that is, we multiply it.
Square.
We square it by, so we multiply it by itself, and that equals 16.
And
so
it's always plus there. Notice that even when we had a negative coefficient, by the time you square it, it's always plus.
Yeah, but when it comes to the binomial, it matters.
Correct. However, we just changed the left side of the equation. I can't arbitrarily do that. What do I have to do to balance it?
We have to, don't we have to take away 16?
Actually, it's on the other side of the equation where we're balancing it. What we were doing the last time we did this was converting these to Vertex Format. And then that number is on the same side of the equation. But about half the time that you're completing the square, it's going to be on the other side. So all you have to do is notice which side it's on. If this 1 was on the left side, then I would subtract 16. But since that negative 1 is on the right side and we're to balance it, now I'm balanced. In other words, all I did was I took my original equation and I added 16 to both sides. That's all I did.
Okay.
Now tell me what binomial that allows me to write it as. Key. Here's the reason we do it.
X plus 4 squared
And the other side?
equals 15.
Now solve that. See, now you can solve this equation. You don't have to factor it. You can solve it by taking the square root of both sides.
So it would just automatically make
do it step by step.
15 doesn't have a.
Hold on. Do it step by step. We're going to take the square root of both sides, right?
Okay.
What's the left side?
Well, it's x plus 2, right?
No. We take the square root of that. It's whatever's inside it.
Oh, okay.
It's, in other words, the square root of something being squared is x plus 4. That's
so I see. And then it just equals 15.
Not 15.
The square root of 15.
Okay, but not even the square root of 15. It's plus or minus the square root of 15.
Oh, yeah.
Don't forget that plus or minus. You always need it whenever you are solving an equation by taking the square root of both sides. First words out of your mouth always should be plus or minus. So, the solution, I'm going to move the 4 over. I'm going to put it there because that's where we're used to seeing these kind of solutions. There's your solution right there. And we solved it by first completing the square, taking that trinomial term, turning it into a binomial term squared, and then taking the square root of both sides. Notice I didn't have to do any factoring. I didn't have to use the quadratic formula. I was able to completely solve this thing that I wouldn't have been able to factor anyway. Notice that x squared plus 8x plus 1 is not factorable.
Mm-hmm.
I would have to use the quadratic formula. Well, what's the quadratic formula give me? It gives me this. Which gives me this. And finally, I'm dividing top and bottom by 2. Same answer.
Okay.
And in fact, the quadratic formula was derived by completing the square. If you did not know how to, if you could not remember the quadratic formula, all you have to do is write it out like this. And solve that by completing the square. In other words, bring the C over to that side, take half of B, and so forth and so on and so forth and so on, and you'll end up with the quadratic formula. Now, there is a little trick yet that we haven't quite run into, but let me see if I can find a problem where we will. Let's not do it yet, though. Let's solve the next one.
What is the actual square for?
That's a good question. I don't know.
I think that's one of the ways she was trying to get us to learn.
That's some special technique she was showing you graphically, and I'm not sure what it is. I know certainly how to do it algebraically. I'm not sure I know how to do it graphically.
Yeah, I don't really remember her going in depth to that. I remember we got out these tiles and tried to make actual perfect squares with the quadratic numbers on the, the numbers in X terms on the tiles.
Yeah. No, I'm not sure where she's going there. and I hate to guess and waste time by guessing. So I think the best thing we could do, if you don't know what those squares are, then I'm not even going to venture a guess. Let's just do these algebraically. I don't think you'll need to know those squares unless she gives them to you on the test and you have to figure out how to do it that technique. But there's no reason to do it that way. Okay, let's do 4, and then we're going to need to do 5, because 5 is different. But we got plenty of time. First of all, let's do 4. What's the first step?
Well, we have to take, we want to put C on the other side, right?
Yeah.
So subtract 25 from both sides.
I could, if my goal was to take this quadratic and put it in vertex format, well, notice what vertex format is. Vertex format is this, and the C or the K is on the same side. So if my goal was to put it in vertex format, so I knew where the vertex was, I would leave that 25 over there. That's not the goal. The goal is to solve the equation by completing the square. So that first step is going to be to isolate those two terms that have x, leave enough room to complete the square. Next step. Next step.
We want to split 2.5.
What's that?
So it's going to be plus 1 next to the 2. And then we can take 1 away from both sides.
No, that would be just doing the reverse.
Yeah.
Got to add 1 to the other side.
Yeah, because we added
1 to the left side. We added 1 to the left side. That's all we did so far. So we can add 1 to the right side. Now, rewrite the left side for me as a binomial squared.
X minus 2. Wait, no, never mind. X minus 1 squared
equals
24 or negative 24.
Next step.
X minus 1 equals the positive or negative square root of negative 24.
Perfect. Now move the 1 over so that we have it in terms of x. In other words, so far we've just solved for x minus 1. We're supposed to solve for x.
Okay. So what you did was you added 1 on that side to get rid of.
Yeah.
And then we added on the other side.
I typically put it up front because this is the form you get when you use the quadratic formula. Okay. Now, that's not quite a final answer. There's one thing wrong. What can I still do?
We can simplify the square.
Okay. So let's talk about what the square of minus 24 is.
It's the square of 6 times the square of negative 4.
Okay, when you're dealing with square roots of negative numbers and you know you're going to have I as an answer, the way I find the easiest to do these is this is always the first step. Pull out that negative 1. Okay, is that true or not? Square root of negative 24 is equal to square root of negative 1 times square root of 20.
Yeah, that's true.
Well, that's I. And now it does turn out that that can be turned into square root of 4 times square
root of 6.
So what's my final answer?
The final answer is x equals 2 times the square root, or I2 times the square root of positive negative I2 times the square. Wait,
Hold on. A little bit ahead of yourself. First of all, that was only the last part of that.
Yeah.
So what we did was we worked out how to simplify that. So in place
So
of
would it
that,
be?
I'm going, in place of that, what, one moment. Hello? In place of that square root of negative 24, I'm going to put this.
Okay.
And I will just erase it.
Give me 1 second, please.
Sure.
I'll be right back.
Uh-huh.
All right, I'm back. Sorry about that.
No problem. So this is our ultimate final answer.
Yeah, I forgot about the one.
Yeah, we still have
minus.
that. I took that up there so we had some room to work with for reducing that. But whenever, if you had something like this, minus square root of minus 73, always do this as your first step. Take out the negative 1, and then you got a positive 73, and now you got square root of 73i. Makes it real simple. If you take out that negative 1 as your very first factor, and square root of 73 is fully simplified. I cannot take it down any further. Okay? All right. 5 has a very a different aspect to it that we need to consider.
It has another
has a coefficient in front of the x squared term.
Yeah, never seen that before.
Well, easy enough to handle. First of all, what? You tell me.
Oh, we can't divide by 3 on both sides. Never mind.
Actually, we can, but I don't like that solution, and I'll tell you why. That's the obvious thing to do, but that would not allow me to point out this extra little thing. So I'm going to do it the hard way, just to show you this. Okay, you with me?
Uh-huh.
Now, you cannot complete the square until the coefficient of the x squared term is 1.
Yeah.
So I got to factor that 3 out. And it could be 3/4. I'd still have to factor it out. Whatever is in front of that x squared, I got to factor out. Okay? So here I'm factoring it out. It's going to leave this. Notice nothing has changed. Same equation as what we started with and as what I started writing.
You just divided that parentheses by 3, or you put it on the outside. You factored it.
And the reason is you cannot complete the square until this x squared has a coefficient of 1. Now, let's complete the square.
So plus 7.
Well, you got to take half of that 14 and then square it. Oh. Remember the word, complete the square, because you're forgetting to do that squaring part.
Okay, so 49, right?
Okay, so just for a second, I'm going to do this. Now, how much did I add to the left side of the equation?
49. So we have to subtract or add 49 to the other side.
No, I didn't add 49. I added 49 times 3.
Oh. So we have to add
147 to the other side. Okay, so that's what I wanted to point out. However, let me back up a step because I didn't need to do it the hard way. I got to add 49 to complete the square, but now can't I divide both sides by 3?
Yeah, you can.
Yeah, so we'll get rid of that 3, turn this into a minus 8, and now, how can I rewrite this, what's completed the square? Now, hold on 1 second, just a second. I screwed something up here.
Didn't you not add the
In my attempt, here, let's go back. In my attempt to show you how to handle that, I messed it up. Or, no, I didn't. Let's see, that was minus 24. I'm going to divide it by, yeah. So that's right. Yeah, we're good to go here. Okay, now how do I rewrite this trinomial?
But I'm kind of a little bit confused. Didn't we add 49 to both sides? Because so when it was minus 24.
Right. Absolutely right. I did screw it up.
Yeah.
Hold on a second. All right, let's go back here. Okay. Clearly, the easiest thing to do here is to factor out. In fact, let's go back to this. Whenever you're faced with a quadratic that you can take a greatest common factor out, always do it.
Mm-hmm.
Because then what you have is this. Correct? Same equation.
Yeah.
All I did was divide both sides by 3, excuse me.
Yeah.
Okay. Now, I'm going to move the 8 to the other side because I want to complete the square. Mm-hmm. Now, I'm going to add 49 to both sides.
Mm-hmm.
And now what I have is x plus 7 quantity squared equals 41. Now, take it from there. Next step.
Next step is going to be to take square root of both sides, which would make it x plus 7 equals the square root of plus minus 41. So plus minus the square root of 41.
Yeah, the easiest way I remember it is make sure the first words out of your mouth are plus minus. And that way you kind of get into the habit of always doing it. And you won't have to add it at the end when you remember it. You know what I'm saying?
Yes.
So what's the final answer? That square root of 41 cannot be simplified.
Take 7 from the one side and subtract it from the other. So negative 7 plus minus the square root of 41.
You got it. Okay. Now, if I erase all of this and make it just slightly harder, make that a 23 instead of a 24, you with me?
Uh-huh.
Now we have to use the other technique. In other words, we can't divide everything by 3 for starters. So I got to do it this way. If you lose me, stop me. Okay. Now I do have to factor out that 3 from both sides. Or rather from the left side. Notice I'm not changing anything yet. If I could remember not to make mistakes. Come on. Same equation, right? And that's always the secret on doing these, is just make sure that when you go from that line to that line, you haven't changed anything. And when I go to that line, I haven't changed anything. Now, when I complete the square and I add 49, I have added 147 to the left side. So I got to add 147 to the right side. Turning that into 124, which is divisible, not divisible by 3. But certainly now I would have x plus 7 squared equals 124 divided by 3, plus minus. Plus minus the square root of that divided by 3. Okay? Now, hold on one second. I gotta get rid of this cat that came into my office here. Big fat cat. Okay. So my point is that when you do have a quadratic that has a coefficient in front of the x squared, you have to get rid of it before you can complete the square. You cannot complete the square otherwise. All right. Let's go to their next one here and see if they actually give you one. When I first saw this, I figured, well, here's one. They're trying to teach you that principle. But then I realized that everything was divisible by 3, so you wouldn't need to do it that way. Okay. Here, they want you to write the quadratic in vertex form. What is vertex form? Tell me.
Ax squared plus x.
No?
No, that's not it.
That's standard form. In other words, the form you just gave me was standard form. Okay? Those are two very common forms. They're giving you this in standard form, notice. Number 6. Well, they want us to write it in vertex form. So I have to take this equation they've given us and make it look like this.
Okay.
That's easy enough to do. What's the first step?
Well, what does H and K represent in terms of?
It is the vertex.
Okay.
You'll understand it more, but for the moment, let's just focus on completing the square. In other words, I'm going to complete the square in this quadratic on number 6 so that I can make it look like standard format. Well, how am I going to do it? I'm going to, first of all, isolate those two. Leave room to complete the square. And that's a minus 19 or a plus. I can't tell. I covered over. It was a plus. Wow, I had covered over it perfectly. I was going to screw things up royal. Oops. That goes out here. Okay? So far, haven't changed anything. What's the next step?
The next step is divide -8 by 2, which is -4. And then multiply that by itself, and it's going to equal 16, so plus 16.
Now, notice that to balance out the right side, what do I have to do?
Add 16.
Now I got to subtract it. I'm dealing on the same side this time.
Okay.
Okay. In other words, algebra, the most important rule in algebra is you can do anything you want to one side of the equation as long as you do it to the other. But in this case, I'm doing everything to the right side of the equation only. So the moment I wrote that plus 16 in there, the way to balance out the right side of that equation is to subtract 16.
Okay.
Okay, now tell me how I can write this trinomial.
Well, it's weird now because we have that outside number.
Don't worry about that yet.
Okay. X
square.
plus X minus 4 squared equals.
Not equal. Just combine those two.
Plus 3.
Okay, that equals y. Okay, notice we have it now in vertex format. Tell me what A is.
A is 0.
It's 1.
Oh, it's 1. So if it's just.
Okay. In other words, when you don't have a coefficient in front of something, it's a 1.
Okay.
It's just not written. In that last case, we had to factor out that 3. A would have been 3. Okay. So A is 1. Tell me what H is.
H is 4, negative 4.
No, it's positive.
Ah, okay, because yeah, it's minus H.
Notice the standard format is X minus H. Well, the only way that results in X minus 4 is if H is 4, positive 4. If H was negative 4, then this would read X plus 4.
Okay.
Okay. And what is K?
K is 3.
H and K are your X and Y coordinates of the vertex.
Okay, so 4, 3.
4, 3. There's the vertex. The vertex format is Y equal X minus 4 quantity squared plus 3. Axis of symmetry is what?
Isn't that the line that goes along the y-axis?
Not the y-axis. It goes through the x coordinates.
Yes, vertically.
Vertical line. It's a vertical line, therefore it's x equal 4. That's the axis of symmetry. It's always x equal whatever that x coordinate is of the vertex. Okay.
Okay.
So if we want to graph that, we know the vertex is approximately right there. So go up or down?
It goes up.
So on what domain, what interval, excuse me, is it increasing?
Infinity.
Well, not quite infinity, from 4 to infinity.
Yeah.
And the 4, it's not either increasing or decreasing, so we put a parenthesis by it. And the infinities always have parentheses. What interval is it decreasing? Go from left to right.
Infinity
Negative.
Negative.
There's a difference. Negative infinity is way over on the left side of my graph. Positive infinity is all the way on the other side of it. So there's a huge difference between negative infinity and positive infinity.
So increasing and decreasing is like horizontally.
Well, if you look at this part right here, you can see that's increasing, right? Every step of the way is it increasing. Same thing here. Every step of the way, that's decreasing. So if negative infinity to 4 is the decreasing. Okay? If I had something like this, it's increasing from negative infinity to there, is decreasing from there to there, and then it's increasing from there to positive infinity.
Okay.
So that's the deal about increasing and decreasing. Just look at it, and if it's going uphill, it's increasing. If it's going downhill, it's decreasing.
Okay.
What's the domain?
The domain is is always negative infinity, infinity, right?
For quadratics, yes. Range, however, is different. Look at that picture. Make your eyes go up and down, left and right.
4 to actually 3, right?
Yes, you know.
3 to
Because this point is 3. And they're talking about the y values. They're not talking about the x values. When they ask you about domain, your answer is in terms of the x value. But when they ask you about range, you're starting at the very bottom and working your way to the top. So what goes on the right side of that 3?
The right side of that 3 is going to be infinity, right?
Yeah. Now, I only made one mistake in that answer.
There's a bracket.
As a bracket around the 3, exactly. Because it can be 3. Whenever x is 4, y is 3. If it can be 3, then you always need a bracket around it. Is it a minimum or a maximum?
This is a minimum.
And what is the value of the minimum? And here they're always asking about the y value.
3.
Good. So that's why you complete the square on a quadratic because, or excuse me, that's why you put it in vertex format, is because you can tell so much with vertex format. Okay.
Yeah.
Let me write the vertex format at the top, and we're just going to do the same drill on this one. If I can get my thing to come up, hold on. So, vertex format is, now on all of these that they're giving you, that A ends up being 1. But it's not always 1. If I have to factor something out of that before I can complete the square, then that thing I'm factoring out, that's going to be A. So tell me how to proceed.
Well, we have to do what we did before, don't we?
Yep.
So it's going to be.
Sure, you know how to do it. Yeah.
All right. It's going to be x squared plus 36.
Hold on.
Actually, x plus.
First of all, the first thing we're going to try to do is just rewrite this without changing it.
Okay.
So the first step is really the parentheses.
Okay, so x squared plus 12 and then leave space for the c, and then we put plus 37 on the other side.
Not on the other side, it's on the same side.
Yeah.
I didn't move it to the other side. The reason I don't want to move it to the other side is, where is that k?
Right there where we put it.
That k is on the same side. Okay?
Okay.
So that's why I leave it on the same side. Now,
So,
complete the square inside the parentheses.
Plus 36.
Okay. Now balance it.
Minus 36 on the outside.
Not on the outside, on the same side.
Yeah.
Okay. Now rewrite it.
X plus 6 squared plus 1.
That's your vertex form right there. That's what goes right here.
All right.
Y equal x plus 6 squared plus 1. Tell me what the vertex is.
The vertex is 6, 1.
No?
Wait, no. Negative 6, 1, right?
Good. Axis of symmetry.
6, negative 6.
It's always a line. It's the equation of a line. I don't know if your teacher will take off for that or not. I honestly don't. You might get away with just saying minus 6. You shouldn't. Because here's what it is. There's the parabola. What you're talking about is that dotted line. That is the axis of symmetry. It's a line, so it needs an equation of a line.
Mm-hmm.
Okay? Okay, where is it increasing?
It's hard because I don't have a visualization of it.
Okay, well, look at what I've drawn over here.
Okay.
Increase from there
to, it's increasing from 1 to infinity.
Okay, they want the x coordinates of where.
Oh, okay. So negative 6 to positive infinity.
Good. And it's decreasing?
From negative 6 to.
No. Always go from left to right.
Negative infinity to negative 6. And it's a bracket for the negative 6, right?
Actually, it isn't. It's a parentheses. Because at negative 6, it's neither increasing nor decreasing. It's a little different than range. When we're talking about range, it is true that y can be 1.
Mm-hmm.
But when x is minus 6, the function is neither decreasing nor increasing. The tangent line to that point would have a slope of 0.
Mm-hmm.
So increasing or decreasing does not happen continuously. In other words, if I have something like that, at this point right there, it's neither increasing nor decreasing. At that point, it's neither increasing nor decreasing. Same thing there. Same thing here. So these points where it changes direction, they are not increasing or decreasing at that point, and that's why we use parentheses.
So on increasing and decreasing, you're almost never going to see a bracket. Well, you're never going to see a bracket, right?
Yeah, pretty much. Unless you had a strange looking function like this. Not all that strange. Exponential function. That's increasing from negative infinity to positive infinity, unless it was closed right there. And it wasn't a line that went to infinity, then you would actually have a bracket on the left and the right side.
Okay.
Let's say that is minus 2. Well, then it would be increasing because at minus 2, it actually is increasing. And let's give that a number of 7, and at 7, it's still increasing. When you look over here at this parabola on the left, at that bottom point, notice it's not doing anything. If I draw a tangent line, that tangent line has no slope, 0 slope. Very key with the calculus. Now what you're getting here is kind of a pre-calculus. Okay? All of these questions they're asking over here on the right side are calculus questions. Just so you know. Okay? And this concept of increasing and decreasing is pretty important from a calculus perspective. And that's why they're asking you these questions. How about domain? Let me erase my other picture here. You don't need this anymore. What's the domain? Domain on all of these quadratics is always the same.
Negative infinity, infinity.
And the range is
1.
1 with a bracket.
Yeah.
Because these are y values. These are not x values.
To infinity.
Correct. Okay. Minimum or maximum?
It's a minimum.
Yeah, whenever they open up, it's a minimum. Whenever they open down, it's a maximum. And what is the value at that minimum?
1.
Correct. There you go. That appears to be the last one on this page. You got another page you want to go to?
Maybe I can just give them these top ones as just to, refresh.
Well, I'm on your website, so if there's more problems on her practice, I can go there.
Okay, let's look.
Okay, let me back up. Completing the square worksheet was quiz next class. Oh, I can't click on that.
Let's do solving quadratics, because a lot of that on there is days that we haven't happened yet.
Okay.
Basically, the bottom half is
click on solving quadratics. Oh, you want the above one? Okay. The October 15th? Okay.
Yeah, I think we've already delved into this one, but just, I think it's good when I get to things.
Oh, yeah. No, for sure. We have not done this one. I do not recognize this. Okay, good. Let me expand it a little bit here and take a picture.
So maybe we have time for a couple of these, and that'll be a good starting point for me to kind of...
Yeah, for sure. Let's tackle this first one. What's the first? Tell me the first thing you notice about it.
Well, you have the x squared with a coefficient, but it's on the one side where the other terms are on the other side. So we have to kind of all bunch them onto one side.
Correct. The first thing I see is I have a d squared and a d and a number. Whenever I see that, I'm putting it in standard format. Standard format is this. Okay. Now, this could be factorable. Let's give it a shot, because if something is factorable, that's by far the easiest way to solve it. And if it isn't, we'll have to go to the quadratic formula. We could also complete the square. There's various ways to solve it. But usually the first two methods you want to try are trying to factor it. And if that doesn't work, use the quadratic formula. So, first step in factoring it is what? Split those up.
Yeah, so we've got that's just, don't we put a 3 on the outside of the first parentheses?
No, when I say split it up, I mean that.
Oh, okay.
The first thing you do in FOIL is multiply those two terms together, right? And you get that. And there's no other d squareds that are going to come in. That first term in the quadratic is always a result of the f from the FOIL. Okay?
Okay.
So, next step. Second step. Determine what?
Determine the factors.
No, determine both sides. In other words, we're doing these piecemeal. I am not going to determine this monomial or this linear factor and then determine this one. That's not the way I do it. I determine both sides. Well, the minus 10 comes from the last two numbers that are multiplied together. So one of those numbers has to be plus, one of them has to be minus. Now, this is a little bit of a hard quadratic because one side has 3D, the other has just D. And so plus minus is not the same as minus plus. So I've got to allow for both. Now, I want factors of 10. Give me factors of 10.
2 and 5.
That's it. We're going to always try the two that are closest together.
Mm-hmm.
And our goal, I'm just going to randomly do it. I'm going to put a, hold on a second. Yeah, I'm going to put a 2 there and a 5 there. I got 4 options, notice. I can do 2 and 5, I can do 5 and 2, or I can do -2, +5, -5, +2. Okay? So, normally I would have to try all 4 of those. But you learn stuff along the way. Okay? Now, first of all, how do I tell if this is correct? In other words, I know I'm going to get 3d squared, and I know I'm going to get -10, so I know those terms are correct. The term that is always the result of 2 terms is that middle term. Well, what's my middle term with this answer?
2d, well, 3d times 5 is going to be 15d.
-15.
Minus 15d.
In other words, you're multiplying that times that with the sign. Okay, now add those 2 terms.
Negative 13d.
Okay, we got the right number, wrong sign. So I know what the answer is. That's all I need to know, is I've got the right number but the wrong sign. And if I move the 2 down to there and the 5 down to there, I will have the right number, the right sign. Notice what happens. That becomes a -2d. That becomes a +15d. That becomes a +13d.
Mm-hmm.
And therefore, I've got the right answer. Now, on these harder quadratics like this double smiley face is a critical part of the technique. It's not just used to check your answer, it's used to find your answer. Because that's what you're doing, is trial and error until you find something that works.
Okay.
Okay, well I did. If I multiply those 2 together, if I FOIL them together, I'll get this starting quadratic. Now tell me my answer. Or answer.
So we have to multiply those together, huh?
No, we just unmultiplied them. That's what factoring is unmultiplying. You're doing foiling in reverse. That's what we did.
Okay, so we just divide?
No. Here, remember this and never forget it. It's the most important thing in algebra. The most important. When you have 2 numbers multiplied together that equals 0, what does one of those numbers have to be?
0.
Okay, always. So the way we're going to solve this is by setting each one of these things to 0. We're going to set 3d minus 7 equals 0, which gives you a d of positive 7/3. And then we're going to set d plus 5 equals 0, which gives you a d of minus 5. Those are both answers to that quadratic. If you go back to that quadratic and you plug in either one of these answers, it will be equal to 0. Okay? So that's how you do it. But the whole point of factoring is so that you can get one thing times another thing equals 0. If I had a 2 over here, I wouldn't be able to solve it. In other words, when I have 2 numbers multiplied together that equals 2, or 3, or 4, there's all kinds of solutions. I cannot say anything specific. There's an infinite number of solutions. It's only when 2 things are multiplied together that equals 0 where you know one of them has to be 0. All right. Let's do, I know we're 1 minute over, but let's do this one just because it's a nice one to do. Number 2, there is no R term.
Just take the square root of both of them, right? You take the square root of both sides.
Okay, so what's the square root of the left?
Well, wouldn't it be, well, it would be 2R.
In other words,
And then the square root of the right would be 5.
Plus or minus 5.
Plus or minus 5, correct.
Okay. And now what?
Divide, we can't divide both sides by 2.
Yes, we can. So the answer is plus or minus 5/2. Notice I didn't have to do any factoring. So when you're missing the non-squared term, it changes the entire nature of the problem. You don't have to factor. I don't have to factor on that one. I don't have to factor on that one. I got to factor on that one because that's got an X term.
Mm-hmm.
But there's no R term there. There's no N term there. There is, but I'm going to get this down to N minus 3 squared. I'm going to divide both sides by 5 for starters, and then I'm going to take square root of both sides. So usually when you can solve a quadratic by taking the square root of both sides, that's what you want to do.
Mm-hmm.
Just that when you have a quadratic like that, how do you do it? You can't take the square root of both sides and get anywhere. I can't do it over here either. I get nowhere by taking the square root of both sides. But here I can do it and solve it. Here I can do it and solve it. And over here I'm going to be able to do it and solve it. So the first thing you have to ask yourself is, which technique are you going to use? And then go from there.
Okay.
Okay? Nathan, you did pretty good in this session. I think you're making some progress.
Thank you.
You're welcome. And we'll talk to you next time.
All right. See ya.